All right, so let's look at this question. We have 2 points, 2 minus 4 and minus 8, 6. We want to find the slope of the line and then a couple of other things, but let's start with the slope of the line. Now, you choose which of these 2 points will be the first point and the second point, because there is a slope definition that we have to follow, rise over run, and that's the difference between the y coordinates and then divided by the difference between the x coordinates, or the delta y over delta x. Okay, changing the y coordinates and then changing the value of the x coordinates. So the slope here, we're going to start with y2 minus y1. So here it is, y2 is 6 and my y1 is minus 4. So this becomes 6 minus 4, okay, over, so that's the change between the y values, over x2 minus x1. So that would be minus 8 minus 2. And then we have to simplify. 6 minus minus 4, that's 10. This is the plus minus beside each other, two negative signs beside each other. That would be a plus. You're adding the two values, minus 8 minus 2, that's minus 10. So this slope here is negative 1. Here we go. So that's the slope of this line segment joining these 2 points together. Okay, the next part of the question is that we want to find the distance between the 2 points, or the distance, the length of the line segment. And remember that the distance between any 2 points, let's call the points A, B, okay? This was given by this relation, x2 minus x1 all squared plus y2 minus y1 all squared. And it's actually Pythagorean, but that's what that is, the difference between the x's and the y's, and then you add them and take the square root of it. And that's basically what that is. So in here, we're just going to plug in values of x1 and x2 and y1 and y2. Now remember again, the two different values, what we have. So what we have is, this is x1, y1, and then x2, y2. By the way, again, you don't have to make the first point the way I did it. You can use the other one as long as you're consistent, okay? So that's what really important. You got to be consistent in terms of labeling the points. So here it is. Now we're going to go through, rewrite it, change the pen. Here it is, square root, big square root. So x2 minus x1, so minus 8 minus 2 all squared plus y2, which is 6 minus 4 all squared. All right, let's simplify. Minus 8 minus 2, that's minus 10 all squared, plus 6 minus 4, that's 6 plus 4, that's 10 squared. So what do we have? We have 100 minus 10 squared is 100 plus 10 squared is 100, and that will be square root of 200. And we can actually simplify this radical, so that becomes 10 root 2. And I'm hoping that you remember what to do there and how we got from the square root of 200 to 10 root 2. All right, so that's the distance between the two coordinates in whatever unit that you want to measure in. So I left the unit alone there, but that's how you find the distance between the 2 points. Right. And the last question is the midpoint of that line segment that we just found, and we found the length of it, we found the slope of it, which is up here, slope -1. Now we want to know the midpoint coordinates of that. So, and the midpoint, remember, is just basically the average. So let me rewrite the midpoint formula, and that's basically it will be x1 plus x2 divided by 2. That's the first coordinate. That's the coordinate of the x for the midpoint. And the coordinate, y coordinate of the midpoint is y1 plus y2 divided by 2. All right, we're just going to plug numbers in. So here it is. The first one will be, so in this case, we got x1 plus x2, and I have 2 plus minus 8 divided by 2. Okay, and the y coordinate is minus 4 plus 6 divided by 2. So we have the y's. This is the y1, that's the y2. We are adding the coordinates and then the x's as well. Let's simplify. So in this case, what do we have? We have minus 6 divided by 2, comma, here is 2 divided by 2. We can simplify more, and that the final answer will be minus 3, comma 1. This is the coordinate of the midpoint of the line segment. Okay,